Good morning, everyone. A hearty welcome to this month's GIS Conversation webinar, where we'll be talking about approaches to smart spatial analysis. Happy to see that we have a great mix of participants from different sectors, both local and overseas. I'm looking forward to interact with you as this program progresses. Before we start, let's do some quick housekeeping. This webinar is being recorded and it will be available by the beginning of next week. You will be receiving an email that includes the link to the recorded webinar. It will also be published on the landing page of the GIS Conversation program. Please feel free to visit the page and give us your feedback on the contents. While the webinar is happening, please feel free to send in your questions through the Q&A panel. I will try to address them at the end of the session. Finally, the webinar will be wrapped up along with some quick announcement. Let's start with a quick introduction to ESRI for the benefit of our friends who are joining us for the first time. ESRI is the market leader in geospatial solutions, and we have been around for more than 40 years with over 1 million users in hundreds of thousands of organizations across the globe. At ESRI, we provide geospatial solutions that allows organizations to derive spatial insights from their data to solve business problems by understanding the relationship between where they are and what is happening around them. This could be retail or commercial clients looking at expansion strategies, insurance and financial companies accessing risks, law enforcement agency looking to keep the community safer, or just anybody looking better ways to stay connected and be engaged with VWOs, community worker, etc. Regardless of the scale of use today, there's a viable solution for all our clients, which why Forrester selected ESRI as the market leader for spatial analytics solution and also the top 10 most innovative companies in the category of data science in another global survey. Before we get rolling with today's presentation, let me introduce myself. I'm Tang Sunyap. As part of the professional service team at ESRI Singapore, I actively work with our client to successfully enable them to make effective use of spatial technology across the organization to solve business problems and maximizing their ROI. Today, I'm going to talk about approaches to smart spatial analysis. The goal today is to equip you with a set of approaches that I think you will apply over and over again every time you do a spatial analysis. I think for most of us, spatial analysis is the main reason why we get into GIS. And just the power of deriving new information, making new interpretation of information, and making new discoveries. We are very excited about the analytic capabilities in GIS, and the idea that you can work with multiple layers is really interesting. One of the goals today, I think for a lot of you, if you are not already, we want you to become data scientists. It is not just getting to know how to use our tool or know how to operate the software. It is another level to reach that point, to explore data, making wise decisions, having that kind of robust knowledge on how to do that. But personally, I think first is to have the tool with you so that you can actually learn by doing, learn through your own work. We are not another Google Maps. We don't just draw maps. When people hear the term data scientist, a lot of things comes to mind. Society might think of us as web makers and mobile app developers, telling them where to go in order to avoid traffic. My friends actually think of me as this person who sit on a desk for 8 hours plus drawing paper maps. But personally, I think that I have the sexiest job in 21st century. Sexy in the sense that we have so much more to offer rather than moving you away from traffic and provide insights to your daily commute. You can often relate data science to this iceberg. As you can see the tip, which may not be massive on the surface, but once you dive underneath, or rather look into the process of data crunching and information processing, this is where the magic of data mining takes place. Similarly, map visualization is just the tip of the iceberg. The huge underneath portion is the spatial analysis. For the purpose of Unity, let's have this working definition of data analytics. Data analytics is the science of examining raw data with the purpose of drawing conclusion about that information. This is the definition from words.com. Data analytics serves not just a workflow for one department of your organization to rely on, it actually serves as a benchmark in terms of establishing of working and a consistent process in providing quality output along the way. Let us be more precise and talking about something which most of us can directly link with ESRI. Spatial analysis is the process of examining locations, attributes, and relationships of the features in the spatial data through overlaying and other analytical techniques. Spatial analysis can help you to address a question or gain useful knowledge about your data. Spatial analysis also can extract or creates new information from existing spatial data. It usually begins with geographic questions, and finding answers to those questions is the main goal of the analysis. I think every spatial analysis problem has two really interesting and commonly used workflows, and they repeat themselves over and over again in your work. The first method is spatial data exploration, where you interact with, explore, and begin to gain insights of your data. And the second method is the spatial problem solving. Every time you go to an analysis, perform an analysis, there's an approach or sequence that we all go through to solve our problem. As you know, there is not much that we can do when we open up a spreadsheet. With smart mapping technology, first thing after we add a layer, it will suggest a various way to display your data. Maps are very interesting because they provide an overwhelming amount of information, and somehow it makes sense of the information, and the graphics on the map is one of the way human communicates. So the idea that you can interact with the map by performing a selection on the graph or chart and see the information in a new way. So these two things, smart mapping and interactive charting and graphing, combined together are the key of spatial data exploration. With ArcGIS technology like ArcGIS Pro or Insights for ArcGIS are really making spatial data exploration to life. Enough about me talking about all these products and tools. Let's see it in action. For my demo this morning, I will be showcasing the power of ArcGIS Pro and on how I can use the analysis tool and smart mapping capabilities inside it to work with two types of data. I will be dealing with healthcare information, which is primarily static, and after that, I will be dealing with temporal data, focusing on crime incidents. It is usual to have tabular data. The first thing that I will normally do is to join the data to the spatial data. In this case, it is the county layer of USA. Hence, we are able to visualize the data on the map using the tabular information. In this demo, I will be visualizing the layers using the average HCC score by county. Average HCC score is the index of measure on health of the population. The higher the score, the more severe the health condition of the population. As I drag the slider to cater the display for the outliers to have a more realistic visualization, now we have the average HCC score display on the map. I can easily do a histogram to show the distribution of the average HCC score. Okay. This histogram created is dynamic. As I select the top few records in the chart, those records gets reflected on the map. I'm also interested to know whether the spending of the beneficiary on health is affected by the average HCC score of the county. Do they simply spend more on their Medicare when they have more serious health problems? I can easily create another histogram and displaying them side by side. As I select the outliers in the average spending histogram, it seems like they are well distributed across the HCC score. In fact, there is a better way to compare these two variables. You can create a scatter plot for these two variables, the average HCC score and the standardized per capita cost. As you can see, the relationship between these two variables is stronger. Let's move on to compare the relationship between various chronic diseases. Do they have any correlation where one disease will tend to lead to another chronic diseases? In this case, let's compare diabetes to hypertension. It seems that these two variables have a slightly stronger correlation among them. If you realize that the layer symbology applied is reflected on the chart as well, we are adding another dimension to the chart, which is the average HCC score. As you can see from the scatter plot, we can not only visualize the percentage of hypertension to diabetes, we are visualizing the average HCC score as well. Let me quickly bring back the histogram in the layer symbology. I can simply drag the upper limit of the slider and make the entire situation become much worse. As a map makers, We want to minimize this subjectivity. In ArcGIS, there is answer to this problem. We provide tools that perform spatial statistics on the data. I have run this analysis beforehand. Whenever you look at the map, your mind and your eyes will naturally try to identify the patterns, the trends, and spatial relationship. The red areas are identified as hotspots, whereas the blue areas are identified as cold spots. The hotspot area have relatively higher average HCC scores as compared to their surrounding areas. Let's move on to the temporal data. On the map, it is showing the crime data in Washington, D.C. As the temporal data suggests, it has the time component to each of the records. I can easily create a line chart to show the trend of the crimes happening. The system will aggregate the data automatically to show the count of crime across time. By default, the system uses a 3 days interval. This parameter can be changed easily. I will choose a bigger number to smoothen the trend, as we are interested to look into the overall patterns. Besides looking at the time component, we can also filter by area. In this case, we are filtering the data by ward using the range slider. And for this demo, I will be choosing single value, as I'm interested to look at one ward at a time. As we move across the different wards, the charts get updated as well. Another cool feature in ArcGIS Pro is that you can group them in different categories. As seen on the chart, in this particular ward, crimes happen in the evening is generally higher as compared to the other shift. Hence, we will be able to identify the different patterns across the different areas. This allows the patrol officers to allocate workforce better according to the trends identified. With emerging hotspot analysis tool, we can identify various trends on our underlying data. It includes new hotspot area or sporadic hotspot area. We can identify potentially new hotspot area or the area are in the diminishing hotspot. In addition, we can also apply space-time cube analysis on the data and visualize them in 3D. Sometimes 2D visualization alone is not able to tell the story completely. When 2D and 3D visualization come together, we can discover a whole lot of new information. It can help to explain why a specific area is identified as emerging hotspot, whereas the other area is not. As you can see the cube on the map, the distance that further from the map is the incidents that happen most distant in time, whereas the cube closer to the ground is the incidents that happen recently. Let's talk about the second key approach. The second key approach is spatial problem solving. What do we do when we approach a spatial problem? I would describe it as a five-step process. Ask, model, interpret, design, and share. The first method is to pose a question. We need to explore our data and try to question on the problem. Some examples would be, is there a pattern in the crime data? Is it by location or by time, or both of them? The second approach is to model and compute. Often we will apply a logical sequence of spatial processing operations to generate a desired set of results. We will have in ArcGIS, there is a lot of tools available that you can apply to transform your existing data into new results. Generally, there are four main categories of the analysis tool. Proximity analysis answers questions like, what features are near other features and what is the distance between them? Features can be within the same layer or within separate layers. Another approach is overlay analysis. Overlay analysis answers the question like, what is on top of what? GIS overlay tools combine features and attributes from multiple layers to create a new set of information. Both the geometries of the features and the attribute of those features are carried through the overlay process. The next approach is statistical analysis. It helps you to identify patterns or relationship in your data to extract additional information that may not be obvious by just looking at the map. Temporal analysis allow you to track, visualize, and analyze the spatial data that move or change status over time. To perform temporal analysis, data should be time-enabled or simply have time values within the attribute table. And often we cannot arrive into our answer by just applying one tool. And in ArcGIS, we offered tools like Model Builder where you can chain multiple tools to achieve your outcome. It's like creating your own algorithm. The third step in the geospatial approach is often overlooked, but is nonetheless still the key component. We are often too sure that the output of our workflows are perfect and correct at all times. However, we must bear in mind that if we somehow put the input data that doesn't match the workflow or is totally irrelevant, then the resulting output will most likely be irrelevant as well. Step 3 highlights the importance of checking your output data by expressing them as map, reports, or charts to interpret the underlying message of the output. Moving on to step 4, once you have interpreted the output, you can start drawing conclusions and even further establish patterns, waves between the data set that you are processing in parallelly. Finally, step 5 is the culminating point that seals the deal out of the whole geospatial workflow. You can present your results using an innovative thematic maps or even use apps such as story maps to extend the message to a larger audience. And even gather feedback from a specific user group from the general public once you have shared your data and results. Let's recap on this second key approach to spatial analysis. Pose a question, model and compute, explore and interpret results, decide, and finally share your results. In summary, we want to introduce the power of analytics to new audience. Spatial temporal is the major focus where people is interested not only in the process, but not the static states. Interactive visualization and analysis can go hand in hand. Okay, do you have any questions? Okay, I have one question here. Can you do interactive charting in ArcGIS Online or Portal for ArcGIS? Okay, for ArcGIS Online, we cannot do it, but we have smart mapping capabilities, wherein for Portal for ArcGIS, there's a premium app called Insights for ArcGIS, where you can perform this interactive charting. If there is no other questions, let's proceed to end the meeting. So take note that the next GIS Conversation Meetup is approaches to spatial analysis. It will be held on 28th July at 4 p.m. at Edward Baustad Center. You can register this, or the GIS Conversation webinar. The next one will be exploring our world with 3D smart apps, which is scheduled on 15 August 2017. These are the upcoming webinars and meetup. You can register it on the website itself by visiting esrisingapore.com.sg/GIS Conversation Series. If you have any queries, please don't hesitate to email me, or you have any kind of feedback, you can send the email to the email that's shown. If then there is nothing, bye bye. Have a good day.